Okay, coming back for the last part of Chapter 10. So with so many platforms available for web developers, it's no wonder that there's so many vulnerabilities, right? Am I right? Am I right? Yes, of course. Now, knowing whether a web application server with an ASP and SQL Server gives gives attackers and security testers both the ammunition to do their jobs, right? The more you know about a system, the easier it is to gather this information about the vulnerabilities and the common misconfigurations, right? So some of those questions you'll ask: do the underlying platforms and concepts contain known vulnerabilities? Is the web server configured to protect the confidentiality of users that connect to it? Are there administrative interfaces to the infrastructure components and the applications that are being tested, right? Et cetera, et cetera. So configuration is very important. So, and many applications require that the server, other than the web server, authenticate users. So for example, Windows Server 2012 running Active Directory services for authentication, right? So it'll examine how authentication information is passed. This is what you want to look at, or encrypted, or is it sent in clear text, depending on the type of Windows authentication you're doing. Windows anonymous authentication, there's basic authentication, there's Windows integrated authentication, or the other often used is Kerberos. Right? Is the server patched, right? Is the information stored in a secure location? Do the user's sessions time out adequately? Do the apps use cookies, right? Does the logout function expire the session, right? All very important questions to ask in terms of authentication. Now, after authentication, there's authorization, right? And so authorization is the act of checking the user's privilege. And a poorly designed application can be found out there. There are many, right? If low privilege users know the URLs to request, they can escalate their own privileges, right? And so insecure direct object references are often discovered during authorization testing. It's something to look at. Now, input validation we've already covered in some detail. Again, it's the act of filtering, rejecting, or sanitizing a user's untrusted input before the application gets it to process it, right? And so problems can lead to database disclosure, for example, right? When web applications accept this untrusted input, an attacker can often craft this malicious request that cause the application to perform an unprotected action, right? And this is where injection vulnerabilities arise. Run code may overfill the buffer, for example, for buffer overflow attacks. So SQL injection is another attack. Who has access to the tables? What database software version is used, right? And so basic SQL statement looks like this. In a SQL injection, attackers are going to insert or inject their own SQL statements within this very SQL statement, right? So remember that the logon form created with the HTML web page that prompts the users for a username and password would look almost the same as any other type of logon form, right? And so the contents of the username and the password parameters are passed to the ASP page for a validation. So input validation, right? Basic testing should look for any number of things. Where can you enter text with punctuation marks? Whether you can enter a single quotation mark followed by SQL commands, for example. Whether you can get any sort of database error when attempting to inject SQL statements. Sometimes a web application will give a tester no indication that a SQL statement was run. And OWASP calls this blind SQL injection, and it has its own set of tests that are required, and you can see them in that pen test checklist that I provided the link in the last section. Now, error handling I've mentioned too. So a web application can be configured or written to handle errors, right? That's a good thing. Developers should minimize the amount of information shared with attackers, right? When you post that error message, sometimes you want a really friendly user message, especially if you're internal to the company, right? But a lot of times you want to limit the information, especially if it's customer facing, right? Optimally, no information or a generic message should be displayed to users in these error cases. And we talked before about common error handling codes, 404, 505, etc. Those would apply, and I wouldn't say much more, frankly. Now, cryptography is the next topic. This is, it can be an intimidating thing, right? To find flaws in the implementation of cryptography, right? So it's not a simple thing, right? There are known weak methods of encryption. Another approach could be self-signing certificates. That's a weakness, self-signing, though lots of companies do it for cost savings. Crypto concepts are discovered in more detail in Chapter 10. So don't worry about it too much, but just be aware as a security tester with these web applications that you would want to do cryptography testing, right, to discover vulnerabilities. Now, business logic refers to the flow a user is expected to follow. It's the logic, right? It's the flow of an application to accomplish your goal. So business logic testing for us involves utilizing creative ways to bypass this logic, these checks, right? So we want to be careful when we do this, but we're also trying to validate to keep the company from being exposed to legal, financial, or even reputational issues. And it should be a focus of your testing, the business logic, right? So, for example, before a wire transfer, you must first satisfy the requirement of having at least the amount of money in the transferring account. If it doesn't have the funds, the transfer should be halted. See, that's the business logic. Now, how can you bypass that, right? So interesting. It's good stuff. There's also, we talked about server-side and client-side testing, right? So client-side issues arise from code executing on the user's machine, typically within the web browser. So often when a developer doesn't want a field to be changed, he or she will use the client side, say JavaScript, to gray out a box. We've all seen a grayed out box in a form. So an attacker, or for example, the accept button has to be clicked before you can submit the form often, right? Accept the rules. That's an example. So an attacker or tester can use an intercepting proxy, right, to tamper with it in transit. So client-side controls are good. They are good, but they're often insufficient. And I prefer application-side controls. And a combination of both are always best, right? So the application stores the sensitive information, and so that's a good way to go. But really, if you can do both client-side, server-side, that is a solid approach, right? Okay, so tools for web attackers and security testers. So after vulnerabilities of a web application or an OS platform are discovered, security testers, and unfortunately hackers too, look for tools that enable them to test or attack the system. And as we've seen in the previous section, all platforms and web application components have vulnerabilities. So there's probably a security hole out there. That's your going in assumption. And now you want to find the tools that you can use to do that. So Some popular tools for hacking web applications include, you could go to the OWASP site, right? In fact, I'm going to pause and put that up there. I've posted two sites on this slide, and you can see it. One is, it's at the OWASP.org site, right? It's appendix for testing tool. And the other is HTTPS. It's called packetstormsecurity.org. I think you'll find those valuable. So as a security tester, you should visit these sites before a test to keep track of any new tools and to browse exploits, right? Exploits posted on the PacketStorm website are often added to Metasploit plugins. Okay. Now, Firefox and Chrome built-in developer tools. These two browsers come with similar set of developer tools that allow us to view parameters in requests, to examine cookies, and even tamper with and send requests, right? So very powerful capabilities there. Now, Burp Suite and Z-Attack Proxy. Burp Suite offers a tester a number of features for testing web applications. And it's going to allow you to intercept traffic between the web browser and the server and inspect and manipulate a request. It can also crawl and scan and brute force some applications. And it has many commonalities with the Z-Attacks proxy, as we've discussed in previous chapters. Wapiti is a web application vulnerability scanner that uses a black box type approach, meaning that it doesn't inspect the code. Instead, it inspects a website by searching from outside for ways to take advantage of cross-site scripting or SQL injections or PHP or JSP and file handling vulnerabilities, things like that. So this allows uploads or command injections, as we've called it, fuzzing, to try and inject data into whatever will accept it, right? In this way, even new vulnerabilities can be discovered. Other scanners search for only known vulnerabilities, right? WFetch is the last one to cover. This is a GUI tool from Microsoft, graphical user interface. Microsoft warns users that WFetch has advanced features, so just be careful, that might expose a server to potential security risks. Be very careful if you do decide to use this. This helpful security tool, though, enables security testers to query web server status and in an attempt to process authentication, right? Okay, and that pretty much wraps up Chapter 10. That was a lot. This is one of the reasons I'll say now and I'll say in the next section. There are 2 chapters in this week. Both are meaty, so I'm just going to stick with the usual discussion and I was going to do a lab, but I'm going to stick with the usual discussion and the assignment, just so that you focus on your risk register and you continue to chew on these chapters. Okay, thanks. We'll see you in Chapter 11.